Hi everyone, today we're going to be working on graphs of simultaneous linear inequations. Before we start the note, I want to make sure that you have at least two colors available to you. So blue and red are good options, green and purple. It doesn't matter as long as the two colors are very different and you can tell the difference between them. Let's get started. It says to find the graphical solution to a pair of simultaneous linear inequations or inequalities, the following steps can be taken. 1. On the same set of axes, I want to sketch each of the inequalities, shading in the unrequired regions. We've already been able to do this. We did this in the last note. And the second part is the solution is represented by the unshaded region. So because we're graphing more than one inequality, there'll be a region that will be unshaded. That's what we're hoping for. So for the purposes of today's examples, we're going to be doing them simultaneously, talking about them and filling out information as well as graphing them. So be sure to follow along with the different pages and the different colors that we're on. So I'm going to use in two colors. My first color is going to be blue for this equation, and my second one in red for this equation. So let's start with the first one. Sketch the graph of x is greater than or equal to 2. Well, x equals 2 is a vertical line. It goes through the x-axis at 2, but it has no y-intercept. Because it has the greater than or equal to sign, we know that it's a solid line. And then it says here in all of this, this is basically telling you to pick a test point. So let's go over here and draw in this line. So I'm starting over here. It's going to go, it's a vertical line where x is equal to 2. Sorry about that, a little shaky here. And then I'm going to pick my test point. So the equation says, the inequality says, x is greater than or equal to 2. I'm going to pick my test point to be 0, 0. That 0 is greater than or equal to 2. Well, that's false. So that means basically I want to shade this whole region over here. So that's what it's saying over here. I want to leave the true part unshaded. So basically I haven't done anything different than I did last class. Now in red, because I have two equations, we're going to graph this inequation on the same graph that I just did. I could use the x-intercept and y-intercept method, or I could rearrange. So please pay attention here. If x plus 2y is less than or equal to 0, then 2y is less than or equal to negative x. So y is less than or equal to negative a half x. Again, I want to use a solid line, and this is telling me to pick a test point and leave the true part unshaded. So basically doing what I did last time. So let's go over here to my graph where y is less than or equal to negative a half x. So I'm going to again start at 0, 0, which automatically means that is no longer a test point for me. And I'm going to graph again a solid line. And I'm going to pick my test point. A good test point here is 1, 1. I could also use 5, 5, anything else that I feel like, but I'm going to pick 1, 1 as my test point. That's 1 is less than or equal to negative a half, so 1 is less than or equal to negative a half. Well, again, that is false. So I'm going to shade the region that contains 1, 1. So we're here. Notice that there is a region that is left unshaded. The last thing that I want to do is figure out my point of intersection. Well, because my graphs are drawn really well, you can see that it's right here at 2, negative 1. Well, let's make sure that's true using algebra. Here are my two equations, x is equal to 2 and x plus 2y is equal to 0. So I'm going to substitute in here. So I get 2 plus 2y is 0. 2y is negative 2. Y comes out to be negative 1. That means the point of intersection is 2, negative 1. So you'll notice that what I got algebraically and what I have on my graph are the exact same thing. Okay, example number 2. These examples are a little bit more challenging because I'm going to ask you to use the x-intercepts and the y-intercepts to graph. So if you'd like to pause the video right now, and graph both of these equations. I'm going to suggest that this one you do in blue and this one you do in another color. Sketch both of the inequations, pick a test point, and shade the appropriate region. That's what I'm going to be doing. So if you'd like to pause the video right now, try it out, see how you do, and come back, that's great. So the first thing it says is find the x-intercept. So I want to make y equal to 0. So that's 2x plus 3 times 0 is equal to 6. 2x is 6, so x is 3. So my x-intercept is 3, 0. And here I want to find the y-intercept. So 2 times 0 plus 3y is 6. 3y is 6. Y is equal to 2. So my y-intercept is 0, 2. So I'm going to, again, have a solid line right here. This tells me it's a solid line. I'm going to go over here to my grid. 3, 0, and 0, 2. Make sure you graph the whole line. Once I graph the line, I want to pick my test point. I'm going to pick 0, 0. That's a handy little point. I get 2 times 0 plus 3 times 0 is less than or equal to 6. That means 0 is less than or equal to 6. That's true. So I want to shade the opposite side, which is above the line. So here, I'm going to go back to my next inequation. Here in the red, I'm going to find the x-intercept. So y is 0. So x minus 0 is equal to 3. So x is equal to 3. So my x-intercept is 3, 0. And I want to find my y-intercept. So 0 minus y is equal to 3. So y is equal to minus 3. So 0 minus 3. Again, it's a solid line. So here, 3, 0, and 0 minus 3. I want to graph in the rest of the line and use a solid line. Once I graph my line, I'm going to pick a test point again. A great test point here, again, is 0, 0. So my test point is 0. 0 minus 0. So 0 is greater than or equal to 3. This is false. So I'm going to shade the region above the line that contains 0, 0. Well, if you look really carefully on my lovely graph, here's my point of intersection at 3, 0. I'm going to now prove that algebraically. So here, I have 2x plus 3y is equal to 6. And I've got x minus y is equal to 3. I may use either substitution or elimination. Because I like elimination, that's what I'm going to use. So I've got 2x plus 3y is equal to 6. I'm going to multiply everything here by 2. So I get 2x minus 2y is equal to 6. I'm going to subtract. So I get 5y is equal to 0. So y comes out to be 0. If y is 0, x comes out to be 3. So my point of intersection is 3, 0, which is verified over here. Notice that the process isn't really very difficult. I'm literally graphing one inequation, shading the region that I don't want, graphing the other inequality, shading the region that I don't want, and then using algebra to find the point of intersection. Give the homework a try and see how it goes for you. See you soon.